So this is important topic related to the motion, that is the equations of the motion. So students taking Cambridge, they must know the derivation also, like how to derive each equation. But student giving at Excel, you will just apply these equations, solving different types of questions, a variety of the questions, but you are not supposed to learn the derivation. But student taking Cambridge, they must learn the derivation of these equations as well. So let's start first about the equations of the motion. As you see, four equations of the motion. The order is not important. Like I can say any one of them as first, second, third, or fourth. For Cambridge students, the order is important. Like for them, like this is equation one. As you derive these equations, this is the equation two for derivation. This one is the equation three, and this one is equation four. But it does not make any difference. In derivation, we derive in sequence. Now, what are these variables stand for? Like example, if we say u, so u means the initial speed or the starting speed. I will derive the equation as well, but student taking at Excel, you don't have to derive the equation, you just have to learn these equations. And students for Cambridge, you have to learn as well as the derivation is also important. V is the final speed. Instead of speed, the better term is a velocity. T is the time for object. S is the displacement. In a straight line, the distance and displacement will be equal. And A is the acceleration. But what is the limitation or the condition for which we can apply these equation? We can only apply these equation if the acceleration is constant. If an object is having a constant acceleration, then these equations are applicable. Otherwise, we cannot apply these equations. Say an object is there at position A, it was moving. S is the distance or a displacement. Actually, it should be displacement, but you can use as a distance as well in a straight line. So an object is there at position A, it is moving at a speed of 3 meters per second. After 1 second, its speed changes to 5 meters per second. After another second, its speed changes to 7 meters per second. So every second, the acceleration, the change is 2 here. So in this case, I can apply these equations according to the given value. But what if the object is not having a constant acceleration? Continuously, the acceleration is changing. Say it was first 3 meters per second, then it changes to 5 meters per second, then it changes to 10 meters per second. So what is the acceleration for the first part? It is 2, and the second part, it is 5. So I cannot apply these equations because it is only applicable for object which is having a constant acceleration. So let's start with the derivation and then we'll do some examples. These are the equations of the motion you have to learn. So derivation of the equation of the motion. Example, there is an object and when you start to observe, it was moving. So like it's originally a moving object is there. So when you start to observe this object, it was moving at a velocity of u. So on x-axis, we have a time. On y-axis, we have the velocity. So on x-axis, we have a time. And on y-axis, we have a velocity. So when you start to observe the object, when we were observing the object was having some velocity, what we call that velocity u. Then the object is having a constant acceleration because you have studied like in a velocity time graph or a speed time graph, if an object is having a constant acceleration, it must be a straight line. Because the slope or the gradient of the velocity time graph represent the acceleration. So the object is having a constant acceleration and after some time, the object is having a new velocity. We call that as v. That's a final velocity. Okay. And the time it took to reach velocity v, we call that time as t. Now, if I want to derive the first equation, like we'll derive these equations separately. If I want to derive the first equation of the motion, student taking Cambridge, you have to learn these derivation as well. So what is the acceleration of this object? The formula for acceleration of an object, the acceleration is refers to change in velocity divided by time. Because I want to reach the first equation, which is v is equals to u plus at. So this time is divided, other side will be multiplied. So I can say a into t is equals to v minus u. U will go other side, so I can say u plus at is equals to v. Or if I rearrange, so I can say v is equals to u plus at. So that is our first equation of the motion. So this is the first equation of the motion which we derive from a movement of an object, like initial velocity was u and it reaches a final velocity v and it takes time t. Is it clear? The first derivation. So in exam, these derivations are there. They asked to derive the equation of the motion. So that's the first equation of the motion. Now, how to derive the second equation of the motion? So if I want to derive a second equation of the motion, if we need the distance traveled, if we need the distance traveled by an object, we have the formula speed is distance divided by time. So distance will be speed multiplied by time. But this object, the speed is continuously changing, like started with initial. So this object is continuously changing the speed. So if this object is continuously changing the speed, in an equation of the motion, the distance given, I'll use a different like example here. Speed is distance over time, or I can use this in place of v. I can use v here. So d is equals to the distance is velocity multiplied by time. But because the object is continuously changing the velocity, it has an initial velocity u and the final velocity v. So what I can also substitute, I can substitute an average velocity. So what will the average velocity? The average velocity will be u plus v divided by 2. And the multiplied by time is t. And the displacement is given by s. So this is a second equation, that s is equals to u plus v divided by 2 multiplied by t. So the average, like the distance covered, is equals to average velocity multiplied by time. And how to take an average of the two numbers? You add them and divide it by the, like sum and divided by the total. So in this case, the sum was u plus v and the total number of the quantity is 2. So u plus v divided by 2 multiplied by t. That is the second equation of the motion. Now, the third equation of the motion, how we can derive the third equation of the motion? As we know, velocity time graph, if we have a velocity time graph, what area under the graph represent? Okay, sure, I will explain the second. See, the object was originally moving at a velocity of u. And it reaches a velocity v. In time t. So we have the formula that speed is distance divided by time, or the displacement in this case, if we write, the displacement will be equals to the average speed, because the speed is changing, or average velocity multiplied by time. Because velocity is displacement over time, but as the object is continuously changing the velocity, so we can say it's average velocity. How to take average of the two number? So the average of these two will be u plus v divided by 2. And multiplied by time, it took time t. and displacement is s. So this is the second equation of the motion, that s is equals to u plus v divided by 2 multiplied by t. Is it clear now, the second equation? Now the third equation, in a velocity time graph, the area under the graph will give us the displacement. This total area, when we take, what it gives us? It gives us the displacement. So what are the two shapes it is making? This is a rectangle, and here is a triangle. So the displacement, according to this graph, the displacement will be equals to area of a rectangle plus area of triangle. What is the area of the rectangle? Area of the rectangle will be length multiplied by width. So the length is the example u. This is a height u, and the width is t. So area will be u into t for a rectangle. What about the triangle? The area of a triangle is half base into height. What about the base? The base is this. And what about the height? If this value is u and this value is v, so what will be this height of this triangle? The height of the triangle will be v minus u, because if we subtract v from u, we get the height of the triangle. So the height of the triangle will be equals to v minus u. Is it clear till this point? Because the area of a triangle is half base multiplied by height. So base is t, but the height is v minus u. Is it clear? Now, from the first equation, A is v minus u over t. So that is from the first equation of the motion. So I can say A into t is equals to v minus u. Means when A is multiplied by t, we get v minus u. So we just substitute. So this is ut plus half t is there. What is the value for u minus v? The value of the u minus v is a into t. So we can substitute a into t. When we further simplify, it will be ut plus half at square. So that will be the third equation of the motion. So the displacement will be equals to area under the graph, which is a triangle and a rectangle. Area of a triangle is u into v. Area of the rectangle is u into v, and the triangle is half t into v minus u. V minus u, according to the first equation, because acceleration is v minus u over t, so v minus u is the product of a and t. So we just substitute the product of a and t there, like we substitute in place of v minus u, we substitute at, and when at is multiplied by t, it will become half at square. So the third equation of the motion, s is equals to ut plus half at square. That's the third equation of the motion. Is it clear, this one? The third equation? So we use the first equation. We use the first equation to get the third equation. Then the last one, we use the second equation to get the fourth equation. Like, what was the second equation of the motion? So it's easy to remember. You will use first with third and second to fourth. Like, according to second equation which we derive. So second equation which we derive, it was u plus v divided by 2 multiplied by t. Is it clear? Like that was the second equation which we derived, that u plus v divided by 2 multiplied by t. Now, and we have the formula, the first equation was v is equals to u plus at. So if I need t from this, if t I need from this equation, it will be v minus u over a will be equals to t. So if I substitute in place of t, I substitute v minus u. So this is example u plus v, or you can also say v plus u. It's the same thing. And what is the value of the t? The value of the t is v minus u over a. In mathematics, you have studied the formula, like if it is a plus b multiplied by a minus b, what you get? You will get a square minus b square. So if it is u plus v multiplied by v minus u, what we will get? We will get v square minus u square divided by 2a. So 2a is divided, other side will be multiplied. So it will become 2as is equals to v square minus u square. So 2as equals v square minus u square. That will give us the fourth equation of the motion. Is it clear? The four equations, the derivation. So you have to learn these derivations, like deriving this, practice these derivations, how to work out first, second, and third equation. Try to learn them in order. Like, as I mentioned, actually there's no order, but for Cambridge student, you should know in order. Like in Cambridge, this is classified as the first equation of the motion, the second equation of the motion, the third equation of the motion, and the fourth equation of the motion. Okay. So we got the first equation of motion by acceleration. We got the second equation of motion by average velocity. We got the third equation of the motion by using the first equation, and we got the fourth equation of motion by using the second equation. Now, this is a word example. For such questions, what you have to do, you have to recall like the things which are given to you. So whenever you read a question, if an object starts from rest, initial velocity will be 0. If an object stops, the final velocity will be 0. And for falling object and object moving against the gravity, we will do later in this chapter. So right now we are only considering the object moving in a straight line. So during the test, the testing of a car, it is timed over measure. In one test, it enter a time zone at a velocity of 50. So it enter a velocity of 50. So what is the starting velocity? Starting velocity is 50. Then decelerate. If it decelerate, for whenever in a question, if it is accelerating, you will take as positive. It is decelerating, you will take as negative. If it is changing a direction, like initial and final velocities are in the same direction, you will take both as positive. If the initial is toward right and final is toward left, then if one is positive, other one should be negative. Any one of them you can take, it's up to you which direction you want to consider. Calculate the velocity of the car as it leaves the measured kilometer. Like example, in one, the track is, the length is for this is 1 kilometer. So the distance which it has to cover, that is 1 kilometer. 1 kilometer means 1000 meters. So the things which we have the initial velocity, we have the displacement, we have the deceleration or acceleration, we need the final velocity. All the equations can work depending on the values which are given to us. Like what if I want to use my first equation? So best thing to solve such question, write all the equations. Like the first equation, you write v equals u plus at. The second equation, you will write s is equals to u plus v divided by 2 multiplied by t. The third equation, s is equals to ut plus half at square. And the last equation, s is equals to u plus v divided by 2 multiplied by t. 2as is equals to v square minus u square. Now we check which equation. If we start with the first one, I need the final velocity. I have u, I have a, but I don't have t. So why I cannot use the first equation? Because two unknowns, so this equation should have a one unknown. If I try to use the second equation, I have displacement, I have the initial velocity, I don't have the final velocity, but I don't have the time. That's why I cannot use the second equation. If I check the third equation, I know the displacement, initial velocity. I don't know the time. I have the acceleration or deceleration, but I don't know the time. We can use this equation as well, but time is not our subject. Like they did not ask for the time. That if they did not ask for the time, then why I should first solve for the time? Even I can use this equation, I can work out the time and then I use any other equation. But directly I cannot use this equation to work out the final velocity. So this equation is applicable, but not useful as we don't need the time, we need the velocity. So if I check the fourth equation, I have the acceleration, I have the displacement, I have the initial velocity, and I need the final velocity, so I can use this equation. That's why when the equation we use the last equation. And we just have to substitute the values. The initial velocity is 50 square, and the deceleration is there. That's why we substitute negative, and the displacement was 1000. So we got 30 meters per second. Now we have the final velocity again. If we need the time, so we can use v is equals to u plus at, the first equation. We have initial velocity, acceleration, and time. The deceleration, we substitute a negative value and we work out. It will take about 25 seconds. And what is the criteria for using such equations? That the object should have a constant acceleration or a deceleration. If an object does not have a constant acceleration or deceleration, we cannot use these equations. Is it clear, this word example? Any doubt in this? Why negative acceleration? Because the object is slowing down. If an object slow down, we have the formula. If an object is moving in a straight line, say v minus u over t, the object does not change the direction. So say if this was 3 meter per second and this is 2 meter per second, and it took example 2 seconds. So if I want to work out the acceleration, the final will be 2. Initial is 3 divided by time is 2. So I will get minus 1 by half, which is 0.5 meter per second square. So in a deceleration, here it's mentioned here decelerate. It is not clear, but it is mentioned here decelerates at a constant rate of 0.8. That's why we took as a negative. If they mention accelerate, then we'll take as positive. So remember, for deceleration, always a negative, and acceleration you will take as positive. Now, what if the object is moving under the influence of the gravity? So if it's a falling object or the object thrown vertically upward, so if an object is launched vertically upward or object is coming down. So if an object is launched vertically upward, it will have some acceleration. It will have the initial velocity, but the maximum height, the final velocity will be 0. And because when it is moving against the gravity, it will always decelerate. So the deceleration will be minus 9.8. This is when objects are moving upward. But what if the object is moving downward? If you drop an object from a certain height, so the downward motion, initial velocity will be 0 and the final velocity will have some value, and its acceleration, because the speed will always increase, it will be 9.8 meter per second square. This is a thing when we divide the upward motion and downward motion into halves. Like when it is moving upward, it's different motion. When it is moving downward, it is different motion. But what if the object, we take a continuous motion? If an object, we are taking a continuous motion, like object is there, we throw vertically upward and it comes down. So here is an object and you are at certain height, like certain position is there. You throw the object, certain height above the ground, and you want to consider the full motion, the upward and the downward motion. Say we launch this object vertically upward. So when we launch this object vertically upward, like here, two motions together, and the trajectory or the path which this object follow, this is the trajectory or the path this object follow. Okay. Like you throw an object from a certain height and the trajectory or the path followed by this object, it's a continuous motion. Before that, the previous example, like I just throw an object vertically upward or I throw an object downward. If it's thrown vertically upward, initial velocity will have magnitude, the final will be zero. But if it's coming down, initial will be zero and the final will have a magnitude. And going up, it is decelerating, coming down, it is accelerating. But what if the object is there, you launch from a certain height and you want to work out the values and treat as a continuous motion. So during the upward motion, velocity is positive, because when we take the continuous full motion, we have to specify, like example, if I'm taking all the upward motions as positive and all the downward motions as negative. Okay. So this is our origin. So from the origin, when I throw something upward, anything which is directed upward will be positive. So the initial velocity will have some positive value. What about the final velocity? The final velocity will be zero at this point, if I take this half. And what about the acceleration here? I will take as negative g. Why I'm taking as negative g? Because the direction of the acceleration is towards it's downward. Acceleration is a vector quantity. It is directed downward. That's why I'm taking acceleration as negative. So during the particle upward motion, the velocity is positive, like upward, and the displacement, any displacement above this point, above the origin, like if object is at position here or object is at this position or anywhere it is above, I will consider that as a positive displacement because it is all above the origin. And during a downward motion, when the particle is moving downward, if a particle is moving down, like example, if I say what is the velocity at this point, or what is the direction of the velocity at this point? If I say final velocity at this point, I will consider as positive. But what if the direction of a velocity at this point? So as it is directed downward, so velocity will be considered as negative. Why I'm considering this velocity as a negative? Because it is directed downward. So two things are different. Some questions you have half motion, some questions you have full motion. So if I say I launch an object with a velocity of 30 meters per second at a height of 2 meters above the ground, and the object is coming down at a velocity of 20 meters per second. So if the initial velocity I take as 30, what will the final velocity I will take as negative 20? Okay, because it is opposite to direction, which I consider all the directions as positive. So rest all of the upward direction is positive. So downward will be considered as negative. Same thing, any displacement above the origin will be positive. Like if I say an object is 2 meters above the position, I'll consider as positive. If object is 5 meters, I'll consider as positive. Object is 1 meter, I'll consider as positive. But what if the object is below the launching point? Then I will consider the displacement as negative. Like it will be 2 meter negative, 3 meter negative. So whenever I substitute the value, if I say an object is at this position, so object is example 1.8 meter above the ground. So what is the displacement of the object? Displacement we measure from the launching position. So what is the displacement from the launching position? It is, because the total is 2. So if total is 2, this will be 0.2 meter. But what I will consider? I'll consider as a negative 0.2. Why we took why I took an acceleration negative in the first part? Because of the gravity is pulling the object towards the ground. So the direction of the acceleration is always towards the ground. That's why I took acceleration as negative. Even for the downward, even at this point, when I'm considering a full motion, I'll also consider acceleration as negative. But why? The reason is that all the places that what is the direction of the acceleration? So direction of the acceleration is always acting downward. Like object, the direction of acceleration is always downward. So when we consider the full motion, you will always take acceleration as negative 9.8 for a full motion. But for a half motion, you will consider upward as negative and downward as positive. Is it clear, this one? Anyone having a doubt or a question till this point about the taking the signs, the sign conventions? So two things are different. Like whenever you approach a question related to this applying the equation of motion, if I independently take an upward motion, so u will have some value, v will be 0, a will be minus 9.8. If I independently take a motion of an object, the downward motion of an object, u will be 0, v will have some value, and acceleration I will take as plus 9.8, the magnitude. When I'm independently solving the two, so this is an upward motion and this is a downward motion. But when I'm solving a question in which the object has a complete motion, like an object is launched from certain height above the ground, and the trajectory which it follows is like this. So anything, all the upward motion, all the vectors which are directed upward, I'll consider positive, and all the vectors which are directed downward, I will consider as negative. So first thing, u, if I say u, because I'm launching it up, so u is positive. If I say v here, v will be positive. But if I say v here, the value of the v, so what will the value of the v here? Because it's going down, so it will be negative. What about a? Because acceleration, direction of acceleration is always towards the ground. That's why I will take acceleration as minus 9.8. What about the value of acceleration here? I will also take as minus 9.8. What about the displacement? Any displacement above the launching position will be positive. Like object is 2 meter above the ground, 5 meter above the ground, 10 meter, and any position below the origin, the displacement will be negative. Is it clear? Anyone having a doubt or a question till this point? Why negative? Even though it's coming down, why I'm taking as negative? Because see, what is the direction of acceleration? Direction of the acceleration is towards the ground. Okay. So acceleration is at any place, the acceleration is always acting downward. Means the change in the velocity will be maximum with 9.8 and it is always towards the center. So all the places for a motion under the gravity, I will take acceleration as down minus 9.8 when I consider the full motion. But when I consider the half motion, I will take as positive 9.8. Because when I'm considering the half motion, all the motions are downward. That's why I'm considering downward direction to be positive. And here all the motion is upward. That's why all the upward directions are positive. But when a complete motion is there, in that case, acceleration will be always considered as negative 9.8. Is it clear? So if I say an object is launched and it follow the trajectory like this. . Yeah, so for full motion, always 9.8. Even the ball is coming down, but for a full motion, it is always negative 9.8. Like if I say an object is launched, it has an initial velocity u here. So what, u should be positive or negative? Positive. If I say what is the velocity v here? Positive. But if I say what is the velocity v here? Negative. And what about the displacement, the distance from the starting position? The displacement, when we take all the displacements are above, so all the displacement will be positive. Why there is negative? As you can see, this object is coming down. So when object is coming down, if all the upward vectors are positive, all the downward vectors should be negative. So if velocity initial, if the final velocity at this point, I will consider as positive. But the final velocity at this point that is coming down, I will consider as negative. Same way, what is the final velocity at this point? It will be negative as well. What about the acceleration at this point? Minus 9.8. What is the acceleration at this point? Minus 9.8. Because the acceleration, just I'm about to complete the session. Shahid, just 2 minutes. So acceleration is always my negative 9.8 for the full motion. But for a half motion, when I divide into half, the positive half, I'll say 9.8, negative, and the remaining half, I'll say at the positive 9.8. We'll do more about this motion under the gravity next session, and I'll take your doubts as well. Any question or doubt you have related to the class today? As some students are having other classes. Any question or doubt related to the class as we did about equations of the motion, derivation?